Suppose you have this following problem, that you have 10 grams of radioactive substance initially that decays to 4 grams after 40 years, and you are asked to express the quantity of radioactive substance at any time t. So this is a standard problem. You want to first say the quantity decays exponentially because it's radioactive decay, so it decays at constant rate. So the substance at time t will have expression c times e to the a times t. We have to find unknowns a and c from the given data. The given data is that at time 0 we have 10 grams of radioactive substance, and we know that after 40 years we have 4 grams of the radioactive substance. Now we will plug in t equals 0 and t equals 40 in this expression for q of t. So this will give us that q of 0 is c times e to the a times 0, which is c, and that is 10. So we'll get our first constant 10 from the first piece of data. And then doing the same thing for 40, which is c times e to the a times 40. Now we know what c is, it's 10, so 10 times e to the a times 40, we know this is 4 from the problem. So we are solving this exponential equation. So how do we solve this is we first divide by 10, so e to the a times 40 equals 4 over 10, which is 0.4. Now we take ln, so ln e to the 40a equals ln 0.4. Logarithm and exponential go away because they're inverse functions of each other, and we're left with 40a equals ln of 0.4. Therefore, a is equal to ln 0.4 divided by 40. Now you can plug this in the calculator and you can obtain the actual number here. Now part B is asking after how many years is the amount 1 gram. So the unknown here is how many years. So unknown is t, which is the number of years. And this data in part B translates to quantity at time t is equal to 1 gram. Now we know what quantity at time t is because we have found c and a. We know, but we haven't written here. Let me write it here. So q of t equals c, which is 10, times e to the a, which is ln 0.4 divided by 40 times t. So q of t is equal to this expression, the exponential function of t. So let's plug big T, unknown t, in this equation, in this formula. So we have 10 e to the ln 0.4 divided by 40 times big T equals 1. So we solve this exponential equation. We divide by 10 on both sides. We get e ln 0.4 divided by 40 times t equals ln 1 over 10. I'm sorry, I'm already taking ln, equals 1 over 10. And then take ln. So ln of e to the, let me write everything, ln 0.4 divided by 40 times t equals ln 1 over 10. The logarithm and the exponential go away with each other, and we're left with ln 0.4 divided by 40 times t equals ln 1 over 10. Therefore, t is equal to ln 1 over 10 divided by ln 0.4 divided by 40. And that's the final answer. That's the number in years.